Okay, let's dive into this. We are going to pull back the curtain on a concept that really secretly powers the most reliable apps and websites you use every single day. It's called idempotency, and honestly, it's the unsung hero of the digital world.
Just picture this for a second, because I know you have been here. You're buying something online, you finally hit pay, and nothing. Just that endless spinning loading icon. The whole screen is just frozen.
So what's the very first thing you do? It's pure instinct, right? You start clicking, you probably hit the refresh button, just hoping to, kickstart the whole thing again.
And that's when that little voice of panic kicks in. Wait a second, did that first click actually work? Did I just accidentally pay for this thing twice?
Now, this isn't just a user anxiety problem. It is a massive, massive challenge in software engineering, especially in what we call distributed systems. Basically, anytime different parts of an application are talking to each other over a network, things can, and they absolutely do, go wrong.
The secret to preventing that whole double charge nightmare is making sure systems can handle the exact same request over and over again without causing a complete mess. The solution, the real hero of our story today, is this powerful concept called idempotency.
So what exactly is this thing with the kind of fancy name? I know it sounds complicated, but the core idea is actually incredibly simple and, well, really elegant.
Here it is, plain and simple. An operation was idempotent if you can run it one time, or 5 times, or 100 times, and the end result is exactly the same as if you just ran it that first time. The first request does the work, all the others, they just have no further effect. We can actually see this same logic in basic math. So take a look at the absolute value function. The absolute value of -5 is 5. Simple enough. But what if you apply that same function again to the result? Well, the absolute value of 5 is still 5. See? After that first operation, running it again and again changes absolutely nothing. In this slide shows a perfect contrast in code. On the left, we've got an idempotent action, setting a user's status to active. You can run that command once, you can run it 100 times, their status just stays active. But on the right, you have a non-idempotent action, adding 1 to a login count. Every single time you run that command, the state changes. The number just keeps climbing up and up. Okay, so we get what it is, but why is this concept so absolutely critical? Well, this is where we see its real power, out in the messy world of complex software.
Let's be honest. The internet is messy. Networks fail, servers get overloaded and time out, and your phone or browser is often programmed to just automatically retry a request if it doesn't get a response. Without idempotency, every single one of those automatic retries could be dangerous, creating duplicate orders, multiple charges, or just corrupting data.
And that's exactly why idempotency is so essential. It's that safety net. It lets engineers build systems that can handle the totally unpredictable nature of the internet. It's really a system that's designed for failure, ensuring that all those automatic retries don't create chaos. And that, right there, is the foundation of any service you can actually rely on.
This all sounds great in theory, but how do engineers actually build this safety net? Well, there are a few core strategies they use to make their operations idempotent.
It really boils down to 3 key techniques. First, you can attach a unique ID to every single request, kind of like a tracking number, so the server knows if it's seen that exact request before. Second, you can use smart database commands that know how to handle duplicates gracefully. And third, you just have to use the right tools for the job, especially when it comes to web requests.
And this right here is a perfect example of using the right tools. When you browse the web, your browser uses different methods to talk to servers. Get, put, and delete are all designed to be idempotent. You can ask for data or delete a resource multiple times, and after the first successful time, nothing new happens. But post is different. Its job is to create a new resource. Hitting a post request twice is like telling the server, hey, create a new thing, and then immediately saying, hey, create another new thing. You're going to end up with 2 separate items. That's why it's the one you really have to watch out for.
So to wrap all this up, if you're building a system, how do you make sure you're doing this right? Well, there are a few golden rules you've got to follow.
So here's your takeaway checklist. For any critical action, like a payment, always use those unique identifiers. And this is so important. Designed for this from the very beginning. Trying to bolt it on later is an absolute nightmare. And finally, you have to test for it. You need to actively try to break your system with duplicate requests just to prove that your safety net actually works when things go wrong.
So now think about this. Now that you know the secret to building these super reliable systems, How many apps that you use every single day are probably skipping this crucial step? How many are operating without that safety net? Makes you think, right?